Yeah, good evening, friends. So today we are here for another session on interview preparation. So let's start. Let's take the first question. So what are the different types of learning methods in machine learning? What are the different types of Yeah, so basically there are three types of learning methods: supervised, unsupervised, and reinforcement learning. So in supervised, what happens? We generate a formula based on the inputs, based on input and output value. In unsupervised learning, we find the relation or association between the input and the between the input values, and we group them basically. And in reinforcement learning, we have an agent which learns through the feedback from an environment. It is of two types: positive reinforcement and negative reinforcement. So let's go to the next question. What is supervised learning? What is supervised learning and what are the types of supervised learning types? So let's make it, what are the types of supervised learning? What are the, because we basically discussed what is supervised. So what are the types of supervised learning? So basically, yeah, Akhil has given the right definition. So what are the types mainly? I'm asking. Yeah, so we can basically divide the supervised learning into two types, namely classification and regression problem. So in classification problem, we can classify the output into different classes, and in regression problem, we have continuous data. We work on the continuous data. So basically it is classification and regression. So what is classification next? What is classification? Yeah, so Akhil is right. In classification, the output is discrete, or we can say categorical. So uh, we have a data set with labeled outputs. If we get a data set with label outputs, we can say it is a classification problem. It works on discrete output value only. So some of the examples of classifications are naive Bayes, support vector machine, logistic regression. So coming to what is regression next. Sorry, it is 3. So what is regression? Yeah, Kelly, you're right. So next is what is regression? Yeah, okay, you're right. So in regression problem, we have basically the output as a continuous data. And we can say example of a regression problem like prediction of house price given the area, location, number of rooms, etc. So there are many types. Basically, we can say linear regression, multilinear regression, multinomial regression. Then we have lasso ridge regression. There are many types of regression programs. So next coming to what is linear regression? Yes, Aleni. Input, not just the input, outputs are also in continuous. So in linear regression, what we have is a linear relationship is there in between the dependent and independent variables, where the independent variables is basically our output and uh, yeah. So Yeah. So it is a supervised learning algorithm in which we find a linear relationship between two variables, one dependent and one is independent. The dependent variable is the input variable and the output variable is the independent variable. So if there is only one independent variable, then we call it as simple linear. And if there are many more than one independent variables, then we call it as multilinear regression, multiple linear regression. Yes, yeah, okay, yeah, right. Regression is done on single variable. The linear regression, maybe you can say, is done on a single variable. If there are multiple independent variables, then we can also do, it is known as multiple linear regression. Okay, so next, what are the assumptions we take for linear regression? What are the assumptions for linear regression? Yeah, okay, multiple, yeah. So what are the assumptions we make for solving a linear regression problem? Yeah, Shalini, you're right. Linearity is an assumption. Yeah, they're linear. They should be linear. They should be means input and output should be linearly dependent on each other. Then we have, yeah, normally distributed. Yeah, you covered all the points. So uh, first, the data which we are considering should be an representative of the population. That is the first assumption. Then we have uh, linear dependency of independent and dependent variables. Then we have, yeah, normally distributed. It should be normally distributed. Yeah. So basically, these are the assumptions. You all are correct. So what happens if assumptions are violated? What happens if assumptions are violated? Yeah, this all could arise. First off, if the violations are light, if they are light, means minor violations are there, then we could still means go with that, but it will have bias and variance. And if it is a strong violation, means majority of the data has violations, then the results will be entirely redundant. So we cannot use this. In that case, linear regression cannot be used. Yeah, model may overfit. It depends on the data set mainly. So coming to the next question. What is logistic regression? Yeah, okay, you're correct. Yeah, yeah. Yeah, Shalini, you're right. Yeah, Pawar, you're also right. Yeah, it uses the logit function. So it is a classification algorithm which can be used when the dependent variable is binary mainly. So let's take the next one. Why is it so popular? Why is logistic regression so popular? No, okay, it is a classification only. So it is so popular because it is simple. It is a very simple and very efficient. In case when we have binary outputs, it is a very efficient method for classification model. Yeah, major industries use these algorithms also. When we have linearly separable classes, it gives very good performance. So we can say that when we have binary outputs, it is the best method. Yeah. So let's take the next one. So what is a decision tree next? Yeah, you're correct. So what is it used for? Uh, Classification or regression? Okay, so decision tree. Yeah. So decision tree is a supervised algorithm which can be used both for classification and regression. Yeah, Power, you're right. So in this case, we can have the dependent variable as both numerical and categorical. Yeah. So basically we have here, we can say if we draw means the decision tree. So this is called the root node. This is called the root node. The middle ones are called the branch node. And these are the leaf nodes. Yeah, Kelly, you're right. So coming to the next one. What is pruning? What is pruning in decision tree? Yeah, Pawar, you are all right. Yeah, there are two types, right? So, okay, okay, you have said it above. Yeah, okay, you're right. So it is basically the process of removing the sections which are not necessary or which are redundant. So pruning basically gives us a smaller decision tree which has greater accuracy and greater speed. Yeah, Shan, you're right. We may miss some information by pruning, but we try to means get the most out of it. Yeah, Vinisha, right. So what is next question? Yeah, Shan, right. So what is entropy in decision tree? Yeah, Akhil, you're right. Avnisha, you're also right. Yeah, I got it. So it is the measure of impurity or randomness. So we can say it basically tells about the variance in the data set. Okay. Yeah, we are coming to that in the next question. What is information gain? So Pawar, uh, you're saying entropy is defined as the entropy gain. So what is basically the entropy gain? Sorry, information gain. Entropy gain. Yeah, correct. So when we are building a decision tree, at each step, when we split the data, we have to decide which feature to select. Okay, so this selection is done by using information gain. It is a measure of how much entropy is reduced when a particular feature is used to split a data. So basically, What you are saying is correct. Yeah, based on info gain, we choose the node. So the node with the highest information gain is chosen. Coming to the next question. What is ensemble learning? Yeah, okay, you're correct. But what is ensemble learning in terms of machine learning? I'm asking. Yeah, okay, you're right. So basically, when we are building models in data science, our main goal is to understand the underlying trends in the data. Yeah, Pawar. Yeah, it can be used to know the reliability of the model. So yeah, we'll be coming into those Pawar. So sometimes when we are building models, the data is very complex for a single algorithm to means learn the trends from that data set. So what we do, we combine different models together to improve the performance. Yeah. So next, coming to the different processes of ensemble learning. So what is bagging? What is bagging? It is an algorithm of ensemble learning only. Yeah, we can say it is an aggregation of several weak learners, right? So bagging stands for bootstrap aggregating. Okay, so what we do, we generate multiple samples of n size. So this is the bootstrap data. So we train multiple models in parallel and then aggregate the results. Yeah, so basically powers, what you said is correct. Okay, next, let's go to boosting. Power, I said what you said is correct. It's an aggregation of several weak learners. So we know ensemble learning is done on both regression and classification. So let's keep the boosting for side a little bit. And in case of bagging, if we have a regression, then how can we get the results? Means we train multiple models, no? Multiple weak learners we are training parallelly. So we get the results from all of those uh, learners. So how can we get the result for bagging in case of regression? So you can say in regression, how can we get the result? Bagging. So I'm basically asking what is the aggregation process for regression problems? Yeah, right. It is average. And for classification, yeah, power, you're right. For classification, we have frequency calculation. Highest frequency means. Okay, so boosting. Also, Akhil, yeah. So basically, I'm asking what is the aggregation method used in regression for bagging? And what is the aggregation method used for classification, for bagging? Okay, let me write. What is the aggregation method? Understood? Yeah. So next, coming to boosting, yeah, you have basically given the correct answers. So what we do in case of bagging, we used to take a bootstrapped data sets and then we trained them parallelly. But in case of boosting, what we do, we create multiple models and we train them sequentially. So basically, we train a model, then the output what we are getting, we train another model on that, so we can means increase the accuracy by that. So boosting, we can say it is used for reducing the bias in the model. Then next is what is stacking. Yeah, Akhil, you're right. We form models to meta learner. Yeah, power. So in stacking, we combine weak models that use different learning algorithms. It is not necessary for them to use the same models. So stacking works by training multiple models, weak models or learners, and then using them together by training our model, training another model called a meta model. Yeah, so you all are correct. So next, what is random forest? Yeah, Power, you're right. We can use n number of different algorithms in this. Yeah, Akhil, you're right. So it combines. Yeah. So it is a combination of multiple decision tree together to get a final output. So basically, we can say the decision trees are the building blocks of random forest model. So we can, yeah, okay, it is the best model we are saying. So why is it so popular? Can you say why so? Why is it popular? This is to say means where it shines. What is the main use of a random forest? Where is it used the most? I'm asking. Yeah. So we can say when the data is means high dimensional data. High dimensional data we have. Okay. So when we have high dimensional data, then random forest are the heroes in that case because it is very fast when we means compared to any other models, this works very fast. As we know, we it basically uh, can work with high dimensional means very good with high dimensional data. So we can say when in case of high dimensional data, it is the best model. Random forest is the best model. So we are going to take the last question of today. So this is basically about random forest only. So which is better? random forest or multiple decision tree? Yeah, Akhil, you're right. But if we have a low dimensional data and we use random forest, then it is just means loss, because we can train it better with a simple algorithm, right? Yeah, Power, you're right. So we can say random forest is the better model out of those, because it basically creates several subsets and trains accordingly. It is more robust, accurate, and it is less prone to overfitting. But when we are working with multiple decision trees, then we don't know if it overcomes overfitting or not. It is accurate or not. It is robust or not. We cannot say. But in case of random forest, we know it is more accurate. It is less prone to overfitting, because it is designed in that way. So that is basically for today. Uh, yeah, yeah, Kelly, you're right. Yeah, so we end our session today here only. Thank you. Yeah, yeah, bye. Thank you.